Tell us about yourself. You know how you got into this, and I know you have a huge YouTube following, and you've done a lot of workshops. You have your homestead out there in Colorado, and you're building your house right now. So you know we've been Harry and I have been collaborating for some time now, about a year, I'd say, and uh, discussing some of these methods. I got a lot out of that last interview you did with Doug Lacey and the ferro cement roofs that he's building, and some of my current sketches. I kind of based those off of what Doug was creating. I'd like to see if I could create something similar to that shape, possibly using an airform. So that's what I'm working on right now. This model of this kind of I was calling it a pendentive vault. It's sort of a dome, but sort of a long rectangular shape with large. So this kind of shape, I think, this would be more easily achieved with a thin shell reinforced cement.
Yeah,
Um,
like the Doug Lacey method you were describing.
yeah, it's kind of similar, but I'm pretty excited about trying this method out with like a magnesium cement and maybe a fiberglass mesh or basalt roving mesh. The theme of today is forms, sacred geometry, and vaults and domes.
Yeah, sweet. So, as Scott mentioned, I use airforms in my building process. I'm Aircrete Harry. I have a YouTube channel called Aircrete Harry, and my journey building started 7 years ago. Like many of you, I wanted to build my own home. I was trying to do it affordably. I didn't want to build a wood stick frame structure like everything else. And so that's where my journey started. And about 7 years ago is when I learned about Aircrete. And I was really intrigued by Aircrete because just before I learned about that, there was another building system. I just taken a workshop called Green Rhino Building System where they taught you how to build using these big blocks of styrofoam. And it was really cool because it was fast, inexpensive, and pretty strong. And I was very close to building one of those structures until I learned about Aircrete. And I was a big fan of cement structures. I lived my whole life in some type of cement structure, whether it's poured concrete or cinder block. Never, I never lived in a structure that was a stick frame with sheetrock. So I was just used to solid structures. And so I was really drawn to the Aircrete because I wanted cement. The other issue I had was the method I just learned using that styrofoam. The whole building sounded like a drum. Anywhere you hit that building, it sounded like a drum. So that was something I was having difficulty dealing with. And probably one of the reasons why I didn't go that route. So in looking at the different building methods that were out there, I fell upon the dome shape because of the airform system. Now, I came across a video similar to this one. It wasn't this exact video, but it was something similar where I saw people using an airform. They were spraying it with a stucco mix. They're using basalt roving rope as a reinforcement. That was the first time I seen that. I was like, wow, no rebar or anything, just this rope. And so I saw this and really liked it because it looked very fast. And you could see this was probably done the same day. So in one day, they were able to build that structure. And so I saw a video like that and I was very intrigued with it. So then I started looking into the airform system, just doing more research. And and at the same time I was doing that, I was experimenting with Aircrete. Now, Aircrete was new at that time. And when I say it was new, I mean Dome Gaia had just came out with Aircrete, and Aircrete existed for decades. It's called cellular cement in the concrete world. But the term Aircrete was given by Hajar for Dome Gaia. And so he was the first person making bricks and showing how you could make these structures. So I really liked that idea. I purchased the machine from him, and it turned out the machine didn't work as advertised. And that's basically what my channel was about at the beginning, was experimenting with this machine, trying to figure out how to make Aircrete. So long story short, I came to the realization that Aircrete, remember now this is 7 years ago, Aircrete was not strong enough, in my opinion, to build with. I had made bricks like 12 inches thick by 12 inches, and I was easily able to crack them with my bare hands. And I said to myself, how am I going to live in a structure that I could literally break with my own bare hands? So that wasn't very appealing to me, the weakness of the Aircrete. So what I came to the conclusion was I would use Aircrete purely as an insulative material. And besides that, again, I was doing a ton of research at the time, and I found that building codes in the country, they would not allow you to build with this material alone. But what they would allow you to build is similar to the structure I just showed. They would allow you to build a reinforced concrete structure. So my thinking was I could build a reinforced concrete shell and insulate that with Aircrete. So that's when I decided to invest in airforms. So the very first airforms that I purchased were from a company called Monolithic Domes. And how do I get this to play here? And these airforms were really expensive, but I was building a prototype. So I had a concept of what I wanted to build. And so I invested the money to build a prototype. Now, this airform, and I bought two airforms. This and the other were about $1,000 each, and I was able to perform my experiment. So this was when I was living back in New York City, and I built my first experimental dome to test out my idea, my concept of building a reinforced shell. So you can see here, this is the first airform I ever purchased and inflated, and I'm spraying this with a stucco mix. So all these are on my YouTube channel if you want to watch and listen to it. And I'm just showing here how you can spray the airform with this cement mix and really in no time have a solid shell built. And so I just demonstrate how you could build. Here I'm showing how I used styrofoam for my window and door cutouts. So I didn't put any cement in that space. And I just put a second coating onto here. Now this dome I built was temporary. I was always intending to knock it down because of building codes in New York. You couldn't build a permanent structure. So this was always meant to be temporary. So I built it very thin with knowing I would be knocking it down in a few months. And there I'm showing I'm using basalt fiber chop in the cement mix. So I'm just gonna skip along. Here was my concept. My concept was building a hard shell reinforced, putting a second airform over that first shell, and using this second airform as a form or mold, because Aircrete was like water. If I just poured it on top, it would just spill out on the floor. So the idea was I'd use this second airform to retain the Aircrete inside. And I also made these spacers. These were Aircrete spacers. And I explained in the video, the purpose was so that the second airform didn't lean or tilt to one side or the other, making the walls thicker on one side and thinner on the other. So I'm just demonstrating here how I'm mounting the airform. And this is the second airform now over that first structure. And the other thought process behind all this was that I could build really fast, because most construction before this was, you're looking at a minimum of 3 months for most structures. And so here I inflate my second airform, and I pour my aircrete in, I pump it in, and there were some mistakes that happened, and that happens a lot when you're experimenting and you're doing something for the first time. But basically, I was able to prove to myself that my concept worked, because this is the aircrete. This portion on the bottom is the aircrete that I was able to pump in to my form before I started having some failures with my pump and the first airform. So there were a lot of lessons learned. But after doing this, I was 100% confident that this idea was going to work. And so then I decided to proceed to the next step, which was to buy a large airform to build the house. And so you can see, I'll just finish this video. You see, after about 3 months, I knocked down the dome, I tear it all down, and then I moved on to my next venture, was getting the large airforms. What I ended up doing then, after I knew, I felt 100% confident the idea would work, I ended up buying the airforms that I would need to build my house. So what you see here are a 20-foot airform, a 22-foot, a 30-foot, a 32-foot, and a hallway tunnel that was 9 feet wide, 9 feet tall, and 40 feet long. And I had this whole big idea for this dome home I was going to design. Now, these airforms are reusable, and I was going to build six. This is insane when I say now, but I was going to build 6 30-foot domes and connect them all, and build my house with the method I just showed, where I'd have reinforced concrete, and then I have about 9 inches of aircrete as an insulative layer on the outside. So these airforms, again, they're reusable. You can use them up to 100 times. And so that was where my mindset was at, is I'm going to build a house using this double airform system. Of course, as time went on, I was doing other experiments where I built a another dome using a different method, where I just I'm trying to find that video now. I just used two airforms and filled the cavity with another cement mix that I call the Epic. So in this process, this was another experiment I did with the same two airforms, only this time, instead of building a hard shell first and then covering it with a second airform and filling that cavity with aircrete, I was doing another experiment with an Epic mix. And this is what's called the Epic mix. It's expanded polystyrene paper infused cement. So what you saw, that green stuff, was paper, and this is a hydro mulching machine. So this was not designed for what I'm using it for. This was designed to spread seeds around a large area, but it happens to work pretty good for mixing cement for my system. So in this machine, I mix my paper, water, and cement, and the idea, and styrofoam beads as well. That's shredded styrofoam beads that I mixed up, and you can see I have the bag, and I dump these foam beads into this machine, and I mix everything up. So I make a great mix. You can see here, that's my Epic mix that has styrofoam, cement, and paper and water all mixed together. And what I end up doing after I get this mixed is I pump it into my double airform system. So there were a lot of lessons learned with this system as well. And if you look at the bottom, the biggest lesson I learned was using this system with these airforms caused the airform to bulge out at the bottom on the inside and on the outside of this form. So the material bulged out, but this was really a half successful experiment because had it not been for the bulging and some other little issues I was having here, this was the first time doing this. Um, I was able to fill the cavity with this epic mix up to about halfway point, just before the curvature of the dome. So I got 8-inch thick walls made using this double airform system. And and here I'm showing with the flare camera, you can see where the mix stopped here, and then this is all air cavity. So this here was another system I was experimenting with using airforms. Now that was great. It was fun, and that was my very first workshop that I had, showing how to make that epic mix and use this new double airform system. Now, my idea and hope was that I could build a dome in a day. Using that system, we could fill it with either Epic or Aircrete and have a dome built in one day. And of course, you know, this was not only just for me to build my house, but to help everyone needing a home and all the homeless out there. So nothing was better in my mind than building a dome in one day that was really inexpensive. That dome was less than $1,000 to build, less than $1,000 in material to build. And it was an experiment. So that was pretty much my beginnings with using airforms. Now, those airforms I showed you, the big downside to it was I was working alone on my property. Now I have my wife and she was here to help me, but she couldn't lift the amount of weight that I could lift. She probably can't even lift a quarter amount of the weight that I could lift. And so I really had no help here on my property. The airforms were hundreds of pounds each. So I had a lot of trouble maneuvering them, getting them set up. And so one day walking through Lowe's, I came across some Tyvek house wrap. And when I saw this stuff, I said to myself, I think I can make an airform with that. And that's pretty much how it started for me making my own airforms. So what I ended up doing was building my own airform from the Tyvek house wrap. Now, um, I'm trying to pull up another video now. Now, the Tyvek was really inexpensive. It was very lightweight. I could easily, I could easily carry the airform myself and pick it up and use it and everything. So here you can see this is a airform made with Tyvek house wrap. Now, at the time I made this, the Tyvek was less than $200 for a full roll. And one roll of Tyvek could build up to a 20-foot diameter dome airform. So this here is a 16-footer in diameter, but this was a massive help to me because I could now make the airform myself for very little money, because the other airforms that I showed you, there were thousands of dollars each. You know, one airform was $5,000 and up to like $9,000 for one airform. And so here you can see this was an airform I made for less than 200 bucks. And It was very light. Now, the only thing that changed between the reusable airform and this airform that I made out of Tyvek was the process in which I built. Now, I say that because the reusable airforms are very strong. You can easily inflate it, stand on it. You could lay all your rebar on it. You could lay your cement on it, and it'll hold its shape. The material is so strong, and with the air pressure, it just holds itself very good. Whereas this Tyvek material wasn't. So I had to learn and come up with the method for applying my cement to it. And really, it just came down to spraying the first 5 to 6 feet from the foundation up and letting that cure with the first layer and building up that first layer before moving on to the next. So with my process using Tyvek house wrap for an airform, it takes about 3 days to build because you gotta spray it, let the cement cure, let the cement have the strength to hold the weight of the next layers of cement. So there's a process to it. Uh, I had troubles with this first one because I sprayed too much cement on it, and the entire airform started collapsing under the weight of the cement. And so I lost about 3 to 4 inches because the whole thing luckily came down evenly and not tilting to one side or the other. That dome is fine. Those 4 inches you don't even notice. And but that was part of the learning lesson as to how to spray these domes. And what you see in this video is just we're applying a stucco mesh wiring as a reinforcing layer. This stucco mesh, the stucco mesh is again at this time was about 60 bucks. Now it's about 80 bucks or so for one row. And I found it was much cheaper than the basalt mesh I was using because the basalt mesh was like $350 for one roll, whereas this was 60 bucks. It was galvanized and it was already designed to be cemented because it's a stucco wire mesh. It looks like chicken wire, but it's a thicker gauge wire and it's designed for stucco, for cement. So that galvanized coating helps prevent rusting. And so that was the process I learned when it came to the airform. Now, okay, so with those airforms that I build, they're all hemispherical. They are half of a circle on a stem wall. That's the big difference. I always put a stem wall on my airforms that are hemispherical. And the hemispherical airforms were the easiest for me to design using the calculator that I have. Now, the calculator is, and I'm going to show you the calculator, it's only for building hemispherical domes. Now, what you see here is what I call my bullet-shaped dome. So, in doing experiments with these airforms made of Tyvek, I discovered that if I remove one of my gore shapes, and when I say gore shape, the gore shape is this triangular piece of material that, would look like an orange peel if you peeled it. So it's triangular shape. That's called a gore when it comes to these airforms. So what I found was if an airform, if my calculator for building a dome airform, if it told me I needed 8 gores to make the diameter that I want to build, and if I removed just one of those gores, I would change the shape of the dome. So what you see here is me removing just one gore, and it went from a hemispherical shape to like what I call a more bullet shape or egg shape, you can also call it. And this was another experiment that I did, and this was a failure, but in every failure, there were a lot of lessons learned. And the lesson learned with this one was I sprayed too much cement on at once, and it ended up collapsing, and it didn't have I don't have videos or pictures of it, but it just ended up collapsing, and the cement was just so strong. I didn't even want to bother knocking it down. So it's like a little cave where I use for storage now. But I just wanted to demonstrate that by removing a gore, you can change the shape of the airform. Now, this file we're about to look at is the file you get when you purchase either a airform pattern from my website, or if you purchase the dome calculator, you get this. You get these files, and so these files here, this particular one is just the process of making an airform. So here I talk about the wood, the size airforms, and you can see here I take a 4x8 sheet, you make a grid pattern, and you mark your measurements for whatever size airform you're making. So in this example, this is a 7-foot diameter airform. And you can see here, you make your markings, then you draw your line to bring all your edges together. And now you can see this triangular shape is a gore. Now your gore is right here. What you see here on this bottom is the stem wall. Me adding material to my gore to build my stem wall so I have the height. So here in this example, this is a 7-foot diameter dome. This is a hemispherical dome. That's one gore to make this pattern. Now, obviously, if you made a 7-foot diameter hemispherical dome without a stem wall, you could not fit in it. It might make a great doghouse, but the model of the man is a 6-foot person. So a person 6 feet tall would not fit in there. But if you had a stem wall, you would. So this is the same dome with a stem wall. And the stem wall also gives you a flat wall space on your dome. And there are a lot of domes that curve in early, and you kind of lose some space in the corners or along the perimeter because of the curvature of the dome. And that's another reason why I like stem walls. And also, you guys were learning about biogeometry. You don't actually ever want to live in a purely hemispherical dome because the energy has a negative effect on the human body. So by adding a stem wall, you change that geometry, and it makes it more conducive to life opposed to a hemispherical. So with these domes, when you're designing them, you start with a circle. And so this is 9 foot, 12 foot, 16 foot. They all get cut in half. And this is your hemisphere. And now you also see what the height is to the peak of your dome. So you could see the different examples. 9-footer is 4.5 feet, 12, 6, 16 foot, 8. Now I live in a 16-foot dome. And had I built the dome without a stem wall, you could see you would have hardly any room to live in there. And these are just other examples. 20 foot, 24, 30 foot. You can see what the height is to the peak. And as I mentioned, I always add a 4-foot stem wall to any dome I'm designing. And so here are more examples of that. 9-footer and a 9-footer with a stem wall. Here you can see the different sizes. 12 foot, 12 foot width, 4-foot stem wall. This is a massive difference between a hemisphere without and a hemisphere with a stem wall. Here's a 16-footer, as I mentioned. The 16-footer we live in is, I'm blown away really by how much space there is in a 16-foot dome. It works out to about 200 square feet. And if you had built a loft for your bed, you'd have even more space inside. I don't have a loft, and I'm still blown away by how much space we have inside. Here's a 20-foot, same deal. And with the 20-footer, as you saw here, with a 20-footer, you would have a 10-foot ceiling height to the peak of the dome. But with that stem wall on there, it's so much higher where you could build uh, a loft area here and have a lot more headroom. And here are the last two examples, 24 foot and 30 foot. This is a great example. The 24-foot hemispherical, you could actually build and completely utilize this space just as it is. But this is what I mean by losing some space along the perimeter of your dome because of the curvature. And then here with the stem wall, you see you gain all your space back. So this is only if you're standing. Obviously, there's a lot of different options you have. Like my idea was always you could build cabinetry here, a bench that doubles as cabinetry, so you could store things, and you could easily sit down here and utilize that space. But there's a lot of options, and I've toured a lot of domes that you could look at on my YouTube channel where they are built like this and they do lose space, but it's negligible, because of the size of their domes. Uh, this you hardly notice that space that's lost. And so um, this is the airform and the stem wall thing, and I really like to press this point that the stem wall is very important for the airforms. Now, obviously, not everybody here is looking to build a dome, um, but I really like to push domes because they are so fast to build. And because of that speed of build that you can do with these airforms, like I like to tell people, because I'm very interested in a lot of building systems like Scott's building with Earth, and I've looked into Earth ships, Adobe bags, Cobb, rammed earth walls. And I really love rammed earth walls. That's probably my favorite because of the different layers you see. And the big thing I say is when it comes to the roof of your structure, I'm a big fan of building an airform. So I say where you can build a square structure. I'll show you another video here where you could build a square structure. You could still have a domed rooftop for your structure. So this is an example where these walls are, this is like an octagon shape, they have flat walls, but this could easily be, a rectangle or just a square. And after you do like your rammed earth walls or adobe bag or whatever type of walls you wanted, you could put your header beam, your concrete reinforced beam that goes on the roof line, and mount an airform like this, inflate it, and now you could have a domed roof. And the benefit of this is your roof can be 2 inches thick max. You don't need more than 2 inches maximum for your structure, for your dome. And you're going to see here, they're going to, this is deflated, obviously, and you're going to see them inflate this airform. Here, they're beginning to inflate it. And so you can get a very good idea how you could have flat walls. You could build it however you want, whatever method you choose to build. And in the end, you can have an airform that you build, or you can half build, or you can contact me to build. And you can have an airform similar to this build that you put on top of your square structure and easily spray a cement. And within a day or two, you can have a roof. made of reinforced stucco cement. So reinforced stucco mesh, basalt chop, or just rebar or basalt rebar. You have many options for your reinforcing material, and then covering it with your cement stucco. And so this is one example where this is not an airform like I build, where my airform starts at the ground and I spray everything. So I really like this for a lot of people because not a lot of people want to build a round home. You might want a square or rectangular structure. And I really like this option for a lot of people. And the other thing I really like, if you decide you want to go that route, is you want to use a mix that goes, let's see. You want to use, this is new to me. I've just learned about this. I don't know if you know about this, Scott, but this KIM material is designed to be either mixed into cement or applied onto cement, and it makes a crystalline structure that turns it your cement waterproof. So you can make water tanks, and you could apply this to the surface, or you could mix it into the cement, and after 30 days, it makes the crystalline structure that seals it. And it seals gaps. It's also self-healing, the concrete. So if there's any cracks develop, it'll self-heal. So this is really good. And this is my number one recommendation if you're going to build a roof like I just described. Or even if you're building a dome like I'm building from the ground up, I highly recommend you get this stuff, you mix it in, and this is guaranteed to make your cement waterproof. So now you have no concerns as far as water. Now, before me learning about this, I was using a latex mix where I use a latex bonding adhesive mixed into my cement, replacing the water. And that also will make your cement waterproof. But I prefer this method here because that crystalline structure and because it's self-healing as well with your cement. So this is a big tip here, being able to use this material. So I'm going to share these links with Scott, or you guys can copy it now, and so he can share it with everyone else here. Now, when it comes to the airforms, another tool that I use is on Monolithic Dome's website, and they have this spherical dome calculator. Do you guys see the dome calculator? All right, I just want to make sure. Um, so this is a great tool right here if you're looking to design your dome. I would start here because you can put your diameter, you could put your height. Like here, I'm doing a hemispherical dome. So 12 is half of 24, and that gives me a hemisphere. But I can change that if I want to do something funky. Let's say 22 feet, uh, and this is what it does. So you can see the different shapes it'll give you. And then also what's great, let me change this back to 12. What's also great is it gives you the radius, and your radius, if you're not familiar, goes from the center of your slab to the edge. Your circumference is all the way around the dome, and your diameter is what this is from one edge to the other is 24 feet. And you can see your surface or your area. So this is the square footage of your floor space. So 24-foot diameter dome gives you 452 square feet. And this is another number that's important for me. The surface area is 904 square feet. So that means this dome shell all the way around is 904 square feet. Now that's really important when you are trying to calculate cost. So what I like to do is if I'm making aircrete, let's just use aircrete as an example. If I'm making aircrete, I know in one 55-gallon drum, I can get 7 cubic feet of aircrete made. So if I know My surface area is 904 square feet, and I know I can get 7 cubic feet from one barrel. I determine my wall thickness. So we're going to say, for argument's sake, 6 inches thick. So now my 7 cubic feet turned to 14 cubic feet. And so now I know with one bag of cement, I can cover 14 cubic feet of that dome. And I need to divide, subtract 14 from 904. And then you can determine how many bags of cement you'll need to build your structure. And obviously that changes if you're making not aircrete and you're just doing concrete and you're going to go 1 to 2 inches thick. So this calculator is vital and I constantly use it. It's a very good resource if you're interested in building any kind of dome. So we'll take the same example now. Let's just say you're going to build a 24-foot square structure or rectangular structure. You don't need 12 feet of height. And this is just to give you a rough estimate. Let's say you only need it to be 4 feet. We'll just go with 4 feet. So this arc here, and I'm sure Scott has talked about the chain method where you hang a chain to determine your angles and then you flip that chain. It's basically the same principle with this app. So you can see this would be the curvature for a short roof on a square structure. Now, there's a little more involved with making a square airform, but this is just to give you a rough idea. It's a great calculator, 50 by 25 feet. And you can see they also have stem wall. So let's say I put my 4-foot stem wall here and there, boom. This line here represents the stem wall from that line down. And so you can see this could be easily 3 or 4 level home that you build, or probably 2 to 3 levels at 25 feet to the peak. Actually, that's 29 feet to the peak because of the stem wall. And again, your volume, it also tells you how much space is inside. Area, here's 1,963 square feet if you built this 50-foot diameter dome. So this is a great resource for building. And here's another one that I use for my concrete. This calculator.net is a great one. You can see here they have slabs. They have holes, round slabs. Here's a circular slab or tube. This is what I would use because I make ring beams. And I'll show you what I mean when I say ring beam. So you can see if you wanted to make steps, this is a great calculator to figure out how much cement you're going to need for any given project. So we'll just use this one here. I'll give you a quick example. 16-foot diameter in feet, depth or height 6 inches, change that to inches, calculate. So this is telling me 100 cubic feet will require 3.72 cubic yards of cement to make this slab. So now I know about how much I need. So if I were going to make a solid concrete slab, concrete slab, I know how much to order from my cement truck, or if I'm buying cement in bags and mixing it myself. But it gives you these measurements. This here, I'll give you an example with this one. Outer diameter would be 24 feet. Inner diameter would be 22 feet. Height 6 inches. I calculate that. And this is telling me 1.34 cubic yards to make a ring beam 6 inches thick. Okay, so I'll show you a video. So this is a ring beam. This ring beam is 8 inches in thickness. And with these domes, and you can see there's a ring beam here about to be poured. This one's done. This one's needs concrete to be poured in. So with the ring beam, when you're building a dome, you only need reinforced foundation for the edge of your dome, where your dome's sitting. On the inside, if you want, you can make this earthen floor. In my case, I filled this with aircrete as an insulator, and then I covered it with a hard coat of concrete. But you could see, oh, this is the video I showed already. So you could see, you can use those calculators, that concrete calculator, to determine all of those geometries and how much concrete you need to be able to fill it with concrete. I'll give you another example of different shapes. So when it comes to these airforms, I showed you the bullet shape, the hemispherical dome, and I just want you to see, this is also on YouTube. This is a dome someone built, and this is more egg-shaped. This is a very large dome. Those are the people who built it. Here's their dome complex, and you could see that the benefit of the reusable airforms, I like to say, if you're going to build something like this structure here, I would say you get 2 airforms, maybe 3. And since they're reusable, you can use the same airform to build each of your structures. And the cost goes down. Each time you use the airform, the price goes down. So if you initially spend $5,000 for the airform, each dome you build, the price goes down and down. And also, another great thing with the reusable airforms is after you build your structure, you could sell your airforms to someone else looking to build, unless you're planning on building more in the future. Otherwise, the reusable airforms, I think, are really good. And another example of the reusable airforms is what I'm doing. In this video, I'm talking about this egg-shaped airform that I had made. So I've had a lot of custom airforms made. I've built a lot of airforms, but I don't make custom airforms. These custom ones, in this case, is an egg-shaped airform. So I had this airform made for 3 purposes. The first was I could dig a hole in the ground larger than this airform, inflate the airform, put it in the hole with a weight on it, and then fill the cavity around the airform to make an underground cistern tank. So, it could be a septic or just a water tank. I could build as many of these underground tanks as I wanted because I'm using a reusable airform. So you can see this is a perfect egg shape. I designed this in CAD. I sent it to the company and they built this airform for me to my dimensions. And so it was really good. So I said 3 things. So the first was an underground cistern tank. The second is an above ground tank. So underground, it would be pointy side down. And the benefits of having an egg-shaped tank underground is, number one, your water will have a natural circulation because of the temperature difference of the water touching the walls of the tank and the water in the center of the tank. That temperature difference causes a circulation, and also because it's egg-shaped. So you get water stored in your tank that won't stagnate because it'll be circulating. It won't freeze because it's underground and it's circulating. And it's an egg-shaped geometry, so energetically it'll be charged with the energy of the ether of the earth. And so that's my second reason. My third is what I'm going to first make with that airform, and that's a little bit different subject, but that's I'll be building an egg using quartz crystal mixed with cement, and this will be a meditation chamber. And I'm really into astral projecting. I've done it many times, And I feel like building this egg made with quartz crystal will help me to get out of my body and hopefully help others get out of their body a lot easier. So anyway, that's a different subject matter. But the point is, the airform, you can see how big this thing is. The shipping container is 8 feet tall and it's on top of a 1 foot railroad wooden tie. And this is 11 feet tall and it's 8 feet wide. So this is a big airform. And again, I designed it for three purposes. And I'm showing you because I just showed you the other home someone built with an egg-shaped design. And I really like the egg-shaped design for domes as well because of the geometry, because of that phi ratio you're going to get in there, because of all the positive energetic things that will happen to you living inside of an egg-shaped structure built with no metal, which is another key important thing, which is why I use basalt chop, basalt mesh, and basalt rebar to stay away from metal when I'm building structures that I'm concerned about the energies. And so when I say that, you saw the other structure, I was using stucco cement to build it with. I mean, I was using stucco wire mesh. That's not a structure I would be staying in. That's more of a storage structure. So for me, it would be my bedroom and probably living room structures would be my biggest concern for energies. And so I would focus on building those with no metals. Whereas the other structures, like my entrance dome and structures you spend little time in, bathroom or whatever, I'll use metal to keep the cost down. And so, anyway, this is my thought process behind constructing my structures and being concerned about biogeometry and having positive energies affect me. So anyway, I think that's really cool. I just laid an egg, I like to say in that video. And so that's my egg-shaped airform. So that was another airform. And I just explained why I like those airforms so much. Now, the other reason I really like airforms, I'm going to show you a video of someone else's YouTube channel. And in this video, uh, they talk about how they went to Haiti form, and the Haitian people there had zero skills at building. They had zero tools, and the person who's doing the voiceover, and you can watch this on YouTube, Dan Hildebrand. He's a cool guy. Communicated with him many times. Really from the heart. He spent a lot of his own money to help these people here build. He dished out his own money to buy air compressor, that stucco spray, and a couple other simple tools. But that was really the extent. The airform is reusable. And you can see these people are building a structure and they have zero experience doing this. What you're seeing is people building for the very first time. And this is what I really like about this, because it really is this easy. Now, in their case, they're on the island of Haiti, and so it's very hot there. And so they're just building a concrete structure. It's very different than what I'm doing because I need insulation, not only to meet building requirements, because I have building codes to comply with, but also I don't want to freeze my butt here in Colorado when it gets cold.
Right.
But if you're in these warm climate areas, you could get away with building a structure just like this. And with these new advanced paints with these ceramic beads in them, you could literally just paint this and have massive effect to the interior temperatures, because these ceramic bead paints will act as a thermal barrier and reflect the heat. So if they painted this dome with that special paint, they could easily get a 20-degree difference in temperature from outside to inside just because of the paint. And so I'm gonna try and fast forward here a little. So you can see they're spraying it with a stucco sprayer. And here they remove the airform. They use wood frame. I'll show you in another video how they use wood framing for windows and door frames. That airform is removed, and now they can build another 99 of these domes with that same airform. And if I had to guess, I would say this dome was done in 2 days. It could have been done in one day, but that main structure was 2 days, and then this finishing work, you're looking at about 2 weeks to finish a dome like this. And this looks to be about a 25 or 30-foot diameter dome. And so that's another example of the speed at which you could build and how little knowledge you need. Now, and for that reason, I really push people who are looking to build their own home, no matter what you want to build. I don't think anything is going to be faster than a dome. So I say you build a dome first, use it to live in, use it as storage, use it for whatever as you build your dream home. Maybe your dream home is an earthship. And depending on how much help you have or don't have, is going to determine how long it takes you to build, which is going to be 3 to 10 years. You know, I've seen videos of people
Yeah.
building 5 years later, they're still building their earthship. I'm like, holy cow, this is too much. And renting a flat somewhere, or renting an apartment somewhere. And so if you have this dome, you could do like I did. I built my first dome here in Colorado um in the year 2019, and I'll show you that dome real quick because I was living in an RV. I had all the airforms to build my dream home, but what I learned moving from the city to living off grid is I learned that it's hard living in an RV, especially when it started getting cold. So it was like November, and the cold was just creeping in through the walls of the RV. We constantly had the heater on, and it was too much. And so I told my wife, I'm going to build a dome now. And so I started building my dome in December. No, in November. And I was finished in December with it. My dome is only 3 inches thick, and I built it using an experimental cement mix called the Epic, which I showed you already in the other video. That dome I was able to build. We've been living in that dome. This is going to be our fourth winter. And we're in that dome because it's comfortable. We like it. And I didn't finish with my other dome projects because I didn't have all the finance. So I was doing workshops starting in 2019 until 2022. And the money that I made from the workshops is the money I was able to use to build the structure. So I have 5 domes standing, but they haven't been completed. I have another 4 domes to build before the entire structure house is finished, which is one 24-foot dome and 8 16-foot domes around it, connected with a hallway tunnel, a ring around it. And so I'm working on that. We're gonna pause on working on that 9 dome project and jump onto another project because I feel like I could get it done before winter hits. Here in December, we still have 60-degree days, so it's pretty nice. But I like to hopefully get it done before that, and that's my hyperbolic paraboloid structure.
Yeah.
So this hyperbolic paraboloid structure, I'll share with you now, is this here. So I have the airform for this. The airform was about $12,000. And again, they're reusable up to 100 times, maybe even more, depending on how well you take care of it. And what you see here is the basic shape of the hyperbolic paraboloid. And I'm showing different options for the same airform. With the same airform, I can have 2 opened ends on the dome. I could have 2 closed ends. You know, I could have a closed end and an opened end, which is what I will be building because mine will be a garage. I'm building a garage workshop, but we're gonna hopefully live in it to get us through winter, and so I could finish the other dome home project. But this is another example of an airform that I've currently have to build this. And this was a quick design. The windows will probably change, skylights might change, but this is 24 feet wide and 64 feet long from end to end. And so it's a big space. I think it works out to like 12 or 1300 square feet. Plus I could put a loft area on the ends here where these domes are. I can make a loft and have, there's a lot of options I have. I've been playing around with the design, but this is just another example of an airform. This is not a dome, but a hyperbolic paraboloid, which happens to be the second strongest structure you could build. The first being a dome because it's a 360 arch, and the second is a hyperbolic paraboloid because you have the bends in two directions. So this is another example of an airform. And I have another one besides that one, which is really interesting because it's a company called Beanie Shells. And this company makes these large airforms that they build their structures with. So it's not a dome. And this voiceover talking here, I'll just skip ahead. So this airform you see going up was done in the 60s. This is probably one of the first airforms made. And the way they built this back in the 60s was they had the airform flat on the ground. They poured all the concrete on top of it, and then they inflated it with all the concrete. And so basically, they're showing how this low air pressure system, and if you think about it, like your car tire only takes about 32 psi. So we're looking at very low air pressures to lift all this massive weight up. So this is a dome, but the company makes these other geometries, these other shapes. And so the famous house built is Robert Downey Jr.'s mansion in California. And this here is the shape. Now, this is not a dome and it's not a hyperbolic paraboloid, but this is a very strong structure because of all the curves. So here they're talking about, they did the computer graphics and they know where the weakness and strength is. Here's the foundation's been laid out, and then they're gonna put the airform on and inflate it. And so this is another reusable airform that you can make 100 of these structures that look like this. And so I really like this for a lot of places. Like I mentioned on my video recently with Mike South, like, all the fires that happened in Hawaii. I said if people got together, came up with a design they all liked, they could have an airform made and everyone could build their own home using the same airform. And you could do whatever you want with the interior, but your structure will be sound. You're talking about this is resistant to everything. Fire resistant, obviously, because it's concrete. Water resistant. You're not going to get any molding. You're not going to get any termites you don't have to worry about. You can see that's the airform being removed. It's tornado proof or resistant, hurricane resistant. You know, you're talking about a structure that is just so solid. And to me, it is beautiful. I just love it. Like these arches, look at those archways. It's just absolute beauty to my eyes. Not everyone agrees, but this is another example of airforms. And they do have square building made with airforms as well, if you're really into square or shapes like that. But I think these are the pictures of Robert Downey's. Yeah, this is Robert Downey Jr., Iron Man's mansion in Hollywood or wherever he is in California. And you can see like what you do with the interior is up to you. You know, if you got a little budget, it won't be as fancy as this. Like that was like $8,000 sofa before. And here
Yeah.
are some other geometry, and this is a hyperbolic paraboloid. So what you see here, again, you could, they don't use in this video, they're not using an airform to build this structure, but this can be also made with an airform. And I really like this because that shape gives you a rectangular footing. So your floor space is rectangular, but your walls are doing what you just saw there.
Sure.
See?
Yeah.
Here's the example. This is a hyperbolic paraboloid shape, not like the one I designed with the domed ends, but this is still the hyperbolic because you have a bend in the two directions. And here you can get an idea of the layout they're showing you there. And I'll show you the exterior. And here's their exterior. So again, the interior is a regular rectangular interior. So everything is straight walls, making it really easy to furnish it and, do your laying out. You don't have to deal with any curves at all. But your structure is massively strong because you have the bend in this direction and then the bend in the other. So this is your hyperbolic paraboloid. And again, you can have an airform made to make this type of geometry. And you could build a bunch of structures like this. Here's the same thing, same airform. Only difference is they put it on top of their foundation where they have a garage. So you can see the garage was built first, this whole concrete portion, and then in our case, the airform is mounted and sprayed and done. So you could easily have uh, a home built, and I'm telling you, you're looking at maximum 2 months to finish the house. Okay, you're looking at 3 weeks to finish your structure and 2 to 3 months to finish the house. But once your structure's up and you have your walls and windows or whatever, even though it's not finished, this is what I would do in my scenario. I would start living in it as I'm working on it. But that's just me. Um, so
Well,
anyway,
yeah, like over time and all the discussions we've had, Harry, that's what really stood out for me was the fact that, I mean, if you're trying to go affordable and ease of construction and, simple technique, um, I feel like the Airform is really high up on the list. I've always been promoting the use of Adobe and Cobb, and beginners can learn that, and you can build a house, and it's great. But in terms of speed and also affordability, having less material, less weight, because the walls are so thin. There's just so many advantages to the thin shell cement. So I think it is a lot of hope for housing people who don't have the funds really to buy a $400,000 house or whatever.
yeah, exactly. And with these structures, price wise, where if you're building yourself, you're looking at approximately $10 to $15 a square foot. Now, if you hire a contractor, you're looking at $150 to $300 a square foot for a contractor to build your home. But if you're building yourself, aside from the initial cost of the airform and equipment, but to build your actual structure, we're talking about reinforcement, your cement, your sand, all the materials you need. And whether you're doing an insulation of Aircrete or Epic or some other insulation material, it works out to about $15, $10 to $15 a square foot. And that's really good. And that's at 6 to 8 inches thick for your wall. And what I'm going to show you, so you could get ideas in your mind, and we're going to show you floor plans for domes, and you'll see different layouts and different options you have for domes. And I added this to one of my videos, and I just thought it was really cool, so I wanted to just share it with everyone here. Um, oh, what one? Okay, yeah. So yeah, I'm gonna go through some other pictures first, so you guys can see some other photos that I put to the side, but we can talk while I scroll through some pictures. So yeah, I'm
Um,
open for any questions.
yeah, at this time, my questions are kind of like, the technical aspects of if you want to do the double shell with the insulative material in between the inner and the outer shell. I understand there's more than one way to do that, right? So you could build a dome on the outside of the first airform and then do another airform and do a shell on the outside of that one. Or you could say do one on the outside and then spray the second shell from the inside. Is that right?
Yeah, so this is the video you're referring to. So
Right.
here you can see this is an aircrete slab. This was about 600 gallons of aircrete, I think, that's used as the insulator. And then on here we put a hard coat of concrete because aircrete doesn't wear well. And anyway, again, all these videos are on my YouTube channel. You can watch them to hear me. I'm doing voiceover. But in this airform, this double shell system Scott is talking about, you can see we're preparing the hold down um, angle iron. So this is angle iron, and we're mounting the first airform here, and then we're going to be spraying it. So this is the first airform is being sprayed. This is a fiberglass mesh on there, like mosquito netting. That's commercial. And so you can see we're spraying it. So after we sprayed this first dome shell, and what's really beneficial for this is where your reinforcement goes. So this was a test. So, but if this were your house, you'd have your rebar, your basalt chop, basalt mesh, whatever. All your reinforcing materials would go on that first dome shell, which is going to also give you your thermal mass on the inside for heating and cooling during winter and summer. And so now what you see is that dome shell, if it were your home, would be maybe 2 inches thick and solid. And so here we're putting the second airform over. This is the fiberglass reinforcing mesh. We're putting over that. You're going to see I inflate it. And then we're going to do the same process again where we spray this. We're celebrating. And then we're going to spray that now with the same stucco mix. And so after that's sprayed, you're also going to see we're going to make the wood framing for the door. So we're making an arch door, and this was the simplest way I can think of doing it, where I just use a sheet of masonite and I bent it and I put it to a square frame, and you can see there. And so here we're laying the mesh from the arch to the dome so that it's all monolithic and it's all one structure. So that's what happens here. And then after that structure is built, and this was also an experiment, the first time I built the double shell dome system. After the two shells are built, we then have a cavity in between those two shells that we fill with aircrete. And here's a pump I made using air pressure. So we mix it up here, put it in here, and then it's being pumped in to fill up that cavity. And so you can see that video on my YouTube, and I'm discussing it, and I'm discussing the mistakes that I made and all this and that. But that's the double shell dome system. Because before that system, the only option you had were the dome Gaia method, where you made bricks and you mortared the bricks together and you built the dome. And if I wanted to do that with insulation, to use the aircrete as an insulation layer, for me, that'd be a lot of work because you need the molds, you need to pour the aircrete, you gotta wait for the aircrete to set up a day, take it out. Whereas this system, in one day, I could fill it with aircrete and be done in one day, opposed to a week or 2 weeks using the brick method because you only have but so many molds to make bricks, each day. So that's will slow you down. So if you don't want to slow down, you want to build quick, that is the fastest method. And that was 3 days. That was about 3 days. First day for one dome, second day for the other dome, third day to fill it with aircrete. So within 3 days, that structure was built. and it's not going anywhere. Right now, that structure is my chicken coop, and I got my chickens in there to protect them from the bears we got.
I assume in order to get that quick setup, you have a pretty high Portland content in there, Portland cement content. Do you know what the pounds of cement per yard is?
Well, I could give you the load is a 3 to 1. So when I say 3 to 1, for everyone who's not familiar, for one bag of cement, which is 92 to 94 pounds, depending where you purchase. So we'll just say that's 100 pounds. I'll add 300 pounds of sand to that 100 pounds of Portland. And that's usually the mix I'll go with for shotcrete because I want it to be strong and sticky. But otherwise, the most I would go to is a 4 to 1 mix, which would be 400 pounds of sand to 100 pounds of Portland. So that's usually the mix. If you're going to do it by the yard, it works out to about seven bags per yard. I have a calculator for shotcrete mix that I send to the concrete company when I'm getting a shotcrete mix, and I can share that with you because the concrete company, the cement company, they also have fly ash. So I usually have fly ash added when I'm ordering cement. But if I'm mixing myself, I don't add fly ash because I don't have it available to me around here.
Thanks.
You're welcome.
Thank you so much, Harry. I really enjoyed your presentation. We all learned a lot, and maybe we can follow up questions with you like through email or even later this evening if you're still around. So.